Hi, hello. So I'm just really curious, who in the audience has heard of Sensu? Put your hand up. Okay, awesome. So you've heard of it. How many of you have a good understanding of what Sensu is and what it does? Fewer, okay. That's awesome. Well, I mean, you're in the room, so clearly you've heard of it. So yeah, I'm Sean Porter, the original author of the Sensu open source monitoring project. And today I really want to just talk about Sensu, where it's going, what we're working on. So yeah, I use PorterTech as my handle. You can find me on Twitter or IRC or many different Slack communities. So we're all technologists, right? We solve our problems with technology. So I really want to just talk about this problem space that we all live in on a daily basis. Ooh, I have a remote, I can move. Awesome. But we also create new problems with technology, right? It's this vicious cycle. And a really good example of this is starting, with how infrastructure has evolved to solve our delivery problems, right? So starting with bare metal, right? Get it? So we had a bare metal host, right, that we wanted to run one or more applications on. And it was fairly simple. I mean, we had some problems of like, how do we get the apps on there? How do we get apps off of it? Do we re-provision the host? We had some utilization problems. So, we wanted a greater sense of agility, packaging, deployment. So we brought around this idea of virtual machines, right? How do we cut up these bare metal machines in a way that give us better isolation, better flexibility? How can we migrate these VMs from one bare metal host to the other? Still feel like that's a little magical, but then we felt like that didn't introduce enough problems. We decided to add containers to the story to get further isolation, a little bit more around service management. And then we were able to package up our apps on that. So really we end up with this sandwich all the way down, and some of our organization has knowledge of which layers work and how they work. But really, it just becomes a little bit more complex. And I think this is true in our industry, right? Complexity is ever increasing. I don't think it's like hyperbolic growth. Like, I think it's fairly linear. Like, it's not getting super crazy, super quick. It's just a gradual increase in the amount of complexity that we deal with. And I mean, this is fine, right? I think we all come to terms with this. This is what we do in the technology industry, and it's exciting and entertaining. But what makes this even more of an issue, though, is like these components going from, a host which doesn't really change that often. You probably have 10 or 100 or 200 of them, maybe 1,000, to VMs, which you're getting more of them, to containers, and these things are all shifting around now on top. Ephemeral infrastructure becomes the normal thing. This idea that we can scale out and scale back in on demand to meet up with, seasonal traffic spikes, that kind of thing. This is the normal thing we see today. And again, I already mentioned this, is the number of things we manage is also increasing. So servers, VMs, containers, now function calls on serverless platforms. It's fine. I think this is where we're very comfortable. Multi-generational infrastructure is a thing, right? Old is forever. New is exciting but fleeting. Anything that we adopt today, we're going to probably be managing and maintaining for the next decade. And the fact that applications span this full technology spectrum, like as our organizations continue and our technology stack grows, a good chance that your application touches many different generations of technology. A good piece of evidence with this is IBM's mainframe business grew by 32% in Q4 of 2017. I mean, they're still selling mainframes. So I think that's a good point to just keep in mind, in that people are still deploying these technologies and maintaining them. To further compound on this issue, we have organizations that grow with this technology, right? It becomes larger. We get silos within it. We get those people with specific knowledge and preferences within a very small subset of our company. Communication between them might not be optimal. So you end up with a need for multi-tenancy within your company. So I think this is the reality that I think we can all agree that we all now live in. If you don't agree, I want to know what that's like, and come talk to me after this talk. I might want to come work with you. So my story, so back in 2010, I joined a company called Sonian. Sonian was an e-discovery or email archiving business. I know, super exciting. But it was on cloud infrastructure in 2010. And that was quite a big shift for what would traditionally be a very enterprise-feeling company and organization. So we were early adopters in many regards. We used Elastic before it was Elasticsearch. We really paved the way in terms of cloud automation on EC2, as well as clouds that no longer exist, like IBM Smart Cloud and Rackspace. So it was an interesting place. And for me, it was really cool as an operator because I ran into these new problems for me, which is we have multiple clouds or public infrastructure. We've got ephemeral infrastructure consuming spot instances and auto-scaling groups to churn through 2 petabytes of data sitting on S3. And public networks, not owning that network stack, not understanding how the underlying infrastructure has been laid beneath me. And then service check investment. I had a good amount of experience with operational monitoring tools in the service check space, and a lot of those tools didn't work given the first 3 problems. Things just broke down because they were designed in an era where these things simply weren't problems. So enter July 2011. I created an open source project on a weekend with a hunch that I could create, take a different approach to monitoring to be able to monitor in this, very ephemeral infrastructure. And immediately after, oh God, I gotta take my phone out of my pocket because I'm tethering. Immediately after, I got permission to publish under the very liberal MIT license for management, and it became an open source project that people started to gravitate towards. And what's interesting is they didn't necessarily contribute straight to the core of this product. It started to create this ecosystem around it, plugins and dashboards and things to really consume the APIs. And that's what excited me greatly because it showed that it had value to people and people would then adopt it and start integrating it into their own projects. And I think that's when I knew that this thing actually had some legs. In February of 2013, I joined a company called Heavy Water. We are a DevOps automation consultancy, and we were doing a lot of Chef work, Puppet work, and then eventually Ansible, and deploying Sensu as part of this reference stack for monitoring for people moving from bare metal infrastructure onto the cloud. Really starting to experience the pain that I did in 2010. We found that when we were doing these projects for larger Fortune 100 companies, Sensu was extremely sticky and valuable to them. So what we ended up doing was pivoting this company from Heavy Water, which was consultancy, to a company called Sensu Inc., which we just did Sensu. And really the overall thing here was that we want to create the next gen of Sensu to take the project, which is now 10 years old, and set it up for another 10 years of success, given the change in our infrastructure landscape, right? We've got Kubernetes, we've got OpenShift, we've got even more ephemeral infrastructure, and then things that are harder to model, like how do we do extreme microsystems or serverless. So what I really want to show you today and talk about in demo is Sensu Go, which is this next product. We've actually gone and rewritten Sensu from the ground up one more time in Go with a different architecture to address these new problems. We're actually going GA with it at the end of November. So it's going to become the main project that Sensu drives. So I really want to just talk about design quickly, because I think this is what set Sensu apart from other tools in the beginning and continues to do so. So it's an agent-based monitoring system. You run an agent on all the things that you want to monitor, whether it be a host, container, or VM. And when it starts up, it says, hello, I'm here. Here's some information about me. I'm a Linux machine. I've got MySQL running on me, maybe a little Apache app. Some context there just to say, here I am. This is who I am. Same can be said when that thing goes away or gets decommissioned or shuts down gracefully. It can say, goodbye, I've done my duty, I'm being decommissioned. This is extremely important today because, again, we scale out, but we also scale back down in at night, that kind of thing, or off season. We also expose a number of APIs in the agent so that we can ingest data from other things, external sources, and then that goes over the transport to a backend. The backend here can actually consume that data do a little bit of state management, expose it via an API, and process it. I'll get more into the details shortly. The same APIs exist in the backend, so you don't actually need an agent to use Sensu. You can just use the backend component if you choose, and simply just throw data into its API's ingestion points. Sensu is a scheduling platform. As mentioned earlier, you peek under any modern tool, and it's yet another cron. So Sensu is yet another cron system. But it's a little bit more powerful, and I'll explain why. But basically, it can instruct certain groups of agents to execute service checks, which will then push data back. So what makes Sensu unique is its pub-sub design, its architecture, in that a backend can target groups of agents based on what are called subscriptions. An agent, when it comes up, self-identifies as a system that has a set of subscriptions. I'm a database server, I'm an app server, I'm a Kubernetes host. And then checks can target those subscriptions and go to those machines coordinated. So if I target production, only my agents in the production subscription will receive that check and then publish the result back. I can also do round robin, so I can say I need one agent within this group to run this check, to collect this data. This is extremely useful when you're doing network device monitoring. I can say, hey, highly available group of agents, I need one of you to execute this check right now on behalf of this external resource. So it's another really useful feature. The backend itself can be clustered, it can scale out. Agents can connect to any one of the backends, and they can fail over to other ones. You can also put a load balancer in front of the backends. This connection is actually just a persistent TCP WebSocket connection, TLS encrypted, and yeah, so you can proxy it. All communication is done over this transport with just events that get context enriched and added to, and then it gets back and processed. This is kind of what an event looks like. You have a timestamp, just an epoch timestamp. You've got entities which can be used to represent anything that you want to monitor, whether it be a container, an application, a function call within it. You can just describe things with this primitive called an entity. And then you can have checks and metrics, which I'll dive into shortly. So the idea with Sensu, and this is where its superpower comes from, is its backend component. So when events come in, we store them in the database. You can access to that data via the API. Having a REST API is extremely helpful because it helps you integrate with other tools. And then you get this pipeline, which allows you to filter certain data out, mutate and transform data into other formats, or scrape data or enrich it, and then handlers to take action on it, whether it be sending an email, SMS, provisioning additional infrastructure, really, more powerful actions. So an event can actually go through multiple pipelines. So if I run a check that looks at the state of something, I can have it send data to multiple data sources. So Sensu can integrate with time series databases like InfluxDB, messaging systems like Slack, incident management systems like PagerDuty, and then log management systems like Graylog. And that's part of Sensu's power. It becomes this like central hub for all of your monitoring data, and then it can push it all out to different sources in interesting ways. So configuration for Sensu is done, see how I'm on time, awesome, is done through the REST API. So anything that talks to the API can configure it. This is a Sensu Cuddle tool, which allows operators from their laptops to interact with it, similar to you would with Kubernetes through kubectl, and a web UI for all those that don't want to live within the CLI. We have role-based access controls built into it and namespaces. So you can have a single Sensu install and slice it up for multiple silos within your organization. So you can give a slice of your monitoring infrastructure to a dev team, to a database team, and they can effectively self-service themselves through that, as well as get assistance from administrators. So I can say, hey, I'm the ops team, here's a standard set of checks, here's your namespace, have fun. So they can add things, customize things further. So it's really all about like how does Sensu enable an organization to get from a very distributed large system and get under one umbrella kind of thing. All storage for state and configuration within Sensu's backend is actually an etcd and replicated amongst all backend nodes. So that means if you use the embedded etcd, you just have to run the backend, and you can run 1, 3, or 5 nodes. Or you can run a separate etcd cluster outside of Sensu and then it's completely detached, which separates your concerns, but it just ends up being one more service that you have to maintain separately. So 3 methods of collection service checks. We're all very familiar with these. It's a script, standard out, exit status code to indicate severity. Check MySQL. So Sensu can use all of Nagios or iSinga plugins, as well as Sensu's community plugins. There's a few hundred of them. So a vast ecosystem that you can leverage. Again, it's all about determining whether something's up or down. Here's an example event that contains an execution. So I could tell an agent I need you to run this check. It'll run it and populate some event data that gets stuck through, goes through the backend pipeline. So it's really all about like how do we monitor symptoms in your infrastructure, whether something is up or down or showing signs that it's going to be in trouble. And then Sensu handles this very simple state machine, maintains some sort of historical context for for those symptoms. The other important thing to point out is Nagios plugins for a long time has this idea of perf data. Earlier today it was mentioned that we throw ridiculous bounds out there because really what we actually wanted was just to get this data. And what's cool is Sensu supports the ability to extract this data and we can create events with metric format which supports multiple dimensions, and then we can do interesting things with it like store it in influx or graphite or OpenTSDB or all of the above, which is really interesting. So we can do more with our perf data than we could existing. One big problem with service checks, however, is dependency management. Again, this morning that got called out. I should really just put your talk up as like a preamble for mine. It's wonderful. Is that when you instruct a machine to run a check, it needs scripts and plugins and dependencies locally in order to be able to run it. So Sensu solves this problem with what's called assets, effectively web resources that you can identify as dependencies for a check to run. So this might be a tar file with a bin directory that contains one or more binaries. And what Sensu will do is it's associated with a check. The agent will fetch it, verify the integrity with a 512 checksum, using SSL verified peer to make sure that you're not fetching a unsafe asset, extract it to a sandbox, add it to the run path, and then execute it. So really it's all about dynamic dependency management through the monitoring tool itself. So service checks are extremely simple, accessible, shareable, as well as there's such a vast variety of plugins out there, really anything under the sun. I mean, the Nagios plugin, there's like 2,000 plugins or something. If there's a device out there, there's got to be some script somewhere that somebody's written that can monitor it. So Events API, I mentioned this earlier in the design section. Really, it's just a way that you can manage entities to describe objects you want to monitor, external checks, so you can have things like backup scripts right to it, and then metric collection. So here's some examples. So here I am just creating an event to register an entity called Leviathan, which is an application. So I can describe things. I could also do this for my network gear, my routers, databases, even AWS services. I can model them in this way. Here I am having a backup script that failed, emit an event to Sensu saying, hey, I failed. Here's why I failed. Tell somebody about it. I can also set a TTL. This one's just saying 6 hours, that expect another result from me within 6 hours. If not, raise an alarm. Effectively a dead man switch, right? So we can know that this backup script is expected to run on a regular basis and we're supposed to get data from it. Here's an example of an application, or in this case, this is copied the slide from the perf data example, but emitting some information about MySQL and writing it to InfluxDB. Another method of data collection, the Sensu agent has a statsd listener on it. If you're familiar with this, it's a very simple line protocol, if you're not familiar with it, I mean, that you can use to increment counters and measure things with gauges, and it does some stats aggregation. This is an example of the line protocol. It's actually very straightforward and powerful, it's just over UDP. And what Sensu agent will actually do is take that statsd protocol, transform it into this normalized metric format, and then that goes through your Sensu pipeline. So it's all about this giant funnel of how do we get all this data into the Sensu pipeline, and then the Sensu pipeline is all about what do we do with this data, what do we care about, what do we drop on the floor, what do we elevate, what do we send out, kind of thing. So I actually just want to make sure that I can do a live demo. When's my talk until? Awesome. All right. I've got you all stuck in here for a long time. All right. So I hope you can see this okay. Let's just get that down there. All right. So this, I'm going to take you on a journey through my terminal. So on my local laptop, I have a very trivial Kubernetes setup. So hopefully you don't have to understand Kubernetes to understand this demo, but I'm just using it as a way of demonstrating how Sensu works in a very ephemeral environment. It's also just a fun way to script up demos. Some information about my Kubernetes deployment, very simple. I've got Helm there, I'm not using it. There's a thing called Kube State Metrics, which is a service I'll demonstrate how it's used later. But basically what it does is measure some things about Kubernetes and expose it via Prometheus endpoint, just so I know, how many pods have been provisioned, how many are in what state, that kind of thing. All right, so for the purpose of this demo, I'm going to go ahead and deploy an app that I've aptly named Dummy. So the Dummy app is a web service. If you're not familiar with Kubernetes, I just deployed containers. So if I curl, I don't want to give that away. So if I curl the dummy app service, it's exposed via this DNS record. I can see that there's two instances. It's being load balanced between the two. And what's interesting about this is that, oh boy, okay, let me just type this out the old-fashioned way. This app exposes a healthy endpoint, which does one thing, really. It says a string, whether it's healthy or unhealthy, uses a status code 200 for OK, 500 for failing. If I post to it, I just cause a failure. So if I rotate it, we can see one is healthy now, one is unhealthy. Damn, that's really small. Let's see if we can make this a little larger for you. And if I post again, it'll let's see. Now they're both unhealthy. That's unfortunate. And now let's get them both healthy again. Awesome. So that's our dummy app. It's just responding, returns its host name, it has a healthy endpoint. It also has a /metrics endpoint. So I've instrumented it with the Prometheus Golang instrumentation tool. So we're getting some Go program telemetry here. So that's it on that application side. If I do a get pods, we can just see the two instances there. So what I want to do next is deploy Sensu Go, the new version of Sensu that's G'ing at the end of this month. So let's just go ahead and deploy that. So I'm just deploying a single instance here. If I do get pods, I can see I've just deployed Sensu backend. It's up and running. That's cool. I'm going to use that Sensu cuddle tool I mentioned earlier to interact with it. So what I'm going to do is run configure, and it's going to prompt me for some information about my install. It remembers that from last time. There's a built-in user called admin, and I'm going to try to remember the overly complicated default password. And here we go on the multi-tenancy stuff. So right now, it's organization and then environment within it. I'm going to use the default, and then I'll walk us through just creating a new environment. So if I do Sensu cuddle entity list, we can see what we're monitoring, which is nothing, right? So that's it, though. We've deployed a Sensu backend. We've got the pipeline up and running. We've authenticated with my CLI. And actually, if I switch over here, all right, how do we get out? Escape. Hate the touch bar on this thing. If we go to Web UI, oh, thank you. So here's the backend also has a Web UI. If we log in here, sweet. Let's cache things from my last time. Awesome. Good job, Sean. Duet, for the purpose of this talk, I'll use Safari, which I haven't launched in a very long time. Oh God, it's got some cache too. All right, here we go. Wicked. All right, so here we can see the very basic web UI. What's interesting is it's multi-tenant as well, so I can switch. Currently, there's only the default org and environment. So let's go ahead and start to build out this deployment a little bit. So I'm going to go ahead and create an organization. So this is top level kind of business units generally get organization. We're going to call it Acme. And then I'm going to go ahead and set it as my default. So when I'm interacting with Sensu, it's going to know that I'm going to talk to this one by default. Okay, now let's create an environment within it. And what's really cool about the Sensu Cuddle is that it has an interactive mode, so it'll prompt me for the flags. I don't need to know everything out of the box. So demo, it knows I'm defaulting to Acme, so let's just click enter. The demo environment. Okay, let's also just quickly set that as our default. Wicked. All right, because I'm lazy, I'm going to use my shell history here. I'm going to create a role called dev that has full read-write access to this organization and that environment within it. I am then going to create a user. I'm going to create a user called demo. I'm going to set the super secretive password of password, give him the dev access. So now this person, demo, has full rewrite access to that slice. If they try to manipulate other namespaces of the Sensu install, they won't be able to do it, nor can they see data that gets published there. I'm going to go ahead and reconfigure my tool to use it. Wicked. If we do a list, again, nothing's monitored. All right, so that we've now set up a multi-tenant Sensu deployment. Let's go ahead and deploy. Let's see, we want to now deploy a sidecar. So basically what we're going to do, this is a common pattern on Kubernetes and other container platforms, is you deploy a sidecar, what it's called, or a dependency service in tandem with your application container. If we do this, we're going to deploy a Sensu agent for each of those dummy app instances out there. So ideally, if I run entity list, we can see that they've now registered themselves with the Sensu system. You can also create agents, agent users, which have limited access to certain namespaces. In this case, this agent user has the ability to connect and write data into Acme demo. So here we go. So we've got these things under management. If I do an event list, we can see we're getting keep alives. So this is the mechanism that we know that agents are still out there and alive. They're effectively like a heartbeat mechanism. If they were to fail to check in, Sensu will raise an event that can then go out to like email, PagerDuty, that kind of thing to say, hey, this thing's supposed to be checking in. Okay, let's create an event handler. So we probably want to be able to send messages somewhere. Let's see. So what's really neat about Sensu Cuddle 2 is that it can read config files from disk, much as just like kubectl for Kubernetes. So here I have an asset. Earlier I mentioned how assets could be used for check runtime dependencies. Same thing could be used for pipeline components. So here I have a Slack handler. Basically, this is where it is on the internet. It's a tarball that includes standard Linux directories. Here's a 512 sum. And we're going to create it within the Acme organization. So much like kubectl, you can do Sensu Cuddle create-f, give it the file. I actually just created this handler last night, so hopefully it works. All right, so that created the asset. So now we can actually go ahead and create the handler. So this handler is basically going to say event checks that use me as a handler. I'm going to send incident notifications to Slack, if that makes sense. So let's create that handler. Wicked. Let me just check what we did there. We're going to debug this together. Oh yeah, and you're also getting my secrets right now. Sweet. Greetings. Config Slack. Invalid. That's a really helpful error message, right? Is it getting escaped out? Good eye, good eye. That's why I have you here. Let's try that now. Wicked. Bonus points. Round of applause, actually. Thank you. So now if I do handler info Slack, we can see that we've created, with Sensu Cuddle through the REST API, we've registered a component in the backend. So let's create a check now. Before we do that, let's do Sensu Cuddle create -f config assets. So let's create, I've got asset containing a whole bunch of NETWAYS plugins, as well as I've got one for a Prometheus collector, which I'll show afterwards. So if I do an asset list, we can see we have our Slack handler one, we've got our check runtime dependencies for both NETWAYS plugins as well as Prometheus collector registered. So now we can create some fun checks. So let's hurry up and create a check for dummy app health Z endpoint. So this will be like your traditional HTTP check, right? So what we've done now, if I do a check info, I don't want to type that out. I've had too much coffee. All right, so we've created a check. What we're saying is we're going to monitor the health Z endpoint with check HTTP. We're going to run it on, I can walk over here, I got freedom. Subscriptions, we're going to run on any agent that identifies as the dummy subscription. We have a runtime asset on check plugins, so if the agent doesn't have it, it's going to fetch it. And this is just within the Acme and demo environment. So now if I do let's see if this thing works. Cool. So we can see we've got, I'll move that to the top. Yeah, I can type. So we can see we're running that check. The agents didn't have that plugin, so they pulled it down, verified the integrity, extracted it into a sandbox, ran the check. Now if I do a post to make one unhealthy, within 10 seconds we should get an update. There we go. So one is unhealthy. Oh God, is it gonna work? Is it gonna work? Oh, I can't even drag things. This is terrible. Let's go full screen, full commitment. Given that that backslash was not actually an error, it should pop up here. While we're waiting for that to happen, let's just toggle them both back so we don't keep getting alerted there. Cool, so they're both healthy now. So we were able to see that we were able to create an asset, create a check, deploy it out to agents. They were able to fetch those dependencies, run it, and then we were able to create incidents that ideally eventually got to Slack. My God, come on. Let's just reload. I mean, it is off my phone, so. All right, well, I'll come back to that one. We don't need to debug anything else today. All right, so let's do another interesting thing. Let's create a InfluxDB instance. So kubectl apply, deploy. We're going to deploy InfluxDB, which is a great time series database. It also is going to have a Sensu agent sidecar. So if we do Sensu Cuddle entity list, we can see that that is now added itself. Ooh, let's have some fun real quick before I forget. Let's scale up the number of dummy apps to 10, just to show how Sensu's discovery and deregistration works. If we do a entity list now, come on Kubernetes, there we go. So now that everything's come up, we've got a lot more. We've just scaled our app up, but we're not that serious. Let's take it back down to 1. So what will happen now is as Kubernetes starts to remove them, and they go down gracefully, Sensu's able to determine that they happen gracefully, and now we're down to just 1. So I think that's one of Sensu's great strengths, is that it's very good in this extremely ephemeral infrastructure. All right, next thing we want to do is, let's create an InfluxDB handler asset. So this is how it's going to fetch it. Sensu Cuddle, -f config handlers. We're going to create an InfluxDB handler. If I do handler info InfluxDB. All right, so this one, what we're going to do is any event, this is a built-in filter part of the pipeline that has metric data that goes to this handler. We're going to send it to this InfluxDB instance with these credentials. Again, don't steal my secrets. So now what we need to do is create a check that produces some metrics. What we're going to do is we're going to collect the Prometheus metric data from the dummy app instance. So let's see. Let's create dummy app Prometheus. And it's just going to scrape that /metrics endpoint. It's going to extract that data into the Sensu format. That's going to go through the pipeline. Ideally, this handler should work, unlike Slack, and write it to InfluxDB. Is it working? It never did work. Come on, Slack. Is it? Oh my God, this is why you're here. Another round of applause. Let's see. Oh, now it's a fresh channel. Oh man, let's see. Okay, we'll come back to it. All right, so if I do Sensu cuddle event list, it's going to be a little ugly. We can see that this check is outputting some Prometheus metrics. Actually, in the InfluxDB line protocol, Sensu's extracting it. Actually, let's see. It's in my history. A little lazy. So, oh my God, I've clearly done this a few times. There we go. Okay. Sweet. So I just hit the Influx API. We can see that we got some series data from Prometheus in there, which is really cool. Let's do a little bit more with it, though. Let's deploy Grafana, which is a great visualization tool. Deploy Grafana. It's got a sidecar as well. So let's go over. Oh, it working. There we go. Thank you very much. It's the demo channel. I should probably read what I configure. Fantastic. So we should actually stop that. We'll see it resolved the next time it runs too. So you could also create filters that are associated with the Slack handler. So we could say, there we go, it just resolved there. I only want to know about these incidents every 30 minutes. Like you can do a little bit of incident management suppression through the pipeline using filters. Very cool. All right, so let's go over to this browser. Hopefully this cache doesn't bust me up. Let's see. Let's go full screen. Admin, password. So this is running on Kubernetes. It's actually gone ahead and provisioned the InfluxDB data source, so we have it as a time series database. Let's create a quick graph. That is not a real one. So we can select InfluxDB. Let's do, everyone loves garbage collection. No. Let's see. Last 30 minutes. We want to group by Sensu event ID. Interval, I think it's 10 seconds we probably want to show. There we go. We can drill down here. So we can see that we're now collecting from this. If I scale that back up, let's go back up to like 6, because now our dummy app's processing orders or something. And what we'll see is when those ones come up, we'll start to see new data over here broken down by those Sensu agents as well. So we've now created a check that's basic, is it up or down check. We've also created one that's tell me information about you. I want to capture it, store it in a time series database, and then visualize it. So Sensu's all about, again, composing this system using best-of-breed tools to solve these very specialized problems. There's not one tool that can do all these given things very well. So that's kind of the model that Sensu uses. It's more of a glue or a framework or a hub piece. Let's see. We've got time for a few more things. Actually, I'm going to deploy what's called a daemon set. Basically, it deploys just a Sensu agent per Kubernetes node in my kube cluster. If I do this, actually, I'm going to do a node exporter daemon set, and I'm going to create a Sensu agent daemon set. So now if I just do a kubectl get pods, we'll do we want to show? So here's the daemon set. So if my Kubernetes cluster was to be larger, I would end up with a Sensu agent on every Kubernetes node. Now what I can use with this is I can have my containers just emit data to that local Sensu agent, which provides a great mean. You don't have to run a million Sensu agents for all your container sidecars. You can run one as a daemon set, expose those APIs, have your apps emit data to it, as well as I can leverage them to monitor Kubernetes itself. Let's just quickly throw these out there. So we can use that Prometheus collector for 2 other checks. We're going to do one for the node exporter, and then we're going to also do it for that state Prometheus service cube state metrics. We're going to measure that as well. So if we do like a Sensu Cuddle event list, it's a little ugly. Let's see. If I could only type on this keyboard. Event info. There we go. So we're now collecting information about Kubernetes. So we're now able to deploy service checks, monitor things on Kubernetes with it. We're also able to monitor and measure with Prometheus metrics. Sensu's all about using established protocols. We're not about introducing new ones, so that's why we use Nagios plugins. We use Prometheus, we use influx line protocol, existing things. We want to just be able to pull it all in, again, funnel it in, pull it through the pipeline, and then put it out to useful places. Sweet, okay. Proof that it resolved, we didn't continue to get spammed there. So that's kind of the demo that I wanted to show. With Sensu Go, how easy it was to deploy, how easy it was to create a multi-tenant environment, how easy it was to start monitoring a fairly functional application. So I think I have a few minutes for questions. Yes. All right, well, first of all, that's my talk. Thank you all for coming.
All right. Who has questions? Dave.
Perhaps an ugly one. How do the agents in the backends talk to each other? How do you manage the TLS part of that? Is that built into Sensu, or is that someone else's problem?
Yeah, so for the last 10 years, Sensu's always used a transport like RabbitMQ or ActiveMQ as the mechanism for inter-process communication. In Sensu Go, it's built into the backend in the agent itself, and it's actually just using persistent WebSocket connections over TLS, and then you can proxy it and load balance it as you like. It's super basic. What we've basically identified over 10 years of Sensu is what value do we get out of the transport, what qualities do we like, and that's what we engineered into the new transport mechanism.
I guess what I was asking was, how do you deal with, DNS, host names, making sure the certificate's resolved, revoking them, all that kind of ugly DNA?
So we use Go Gorilla for the WebSocket server, and it supports like standard CA certificate chain configuration. But in terms of like rolling out changes to that, it still relies on like configuration management like a Chef or Puppet or Ansible to do the rolling certificate change. The thing is like in tandem with the RBAC model, you don't have to rotate your certificates as much because you at least have user permissions tied to specific groups of agents as well. So it's kind of like you come up with your own strategy of how you want to keep this thing secure and moving forward as you decommission infrastructure. Does that answer your question?
Yeah, and follow up, can the agents in the back end talk to each other in both directions, or is it just one?
It's bidirectional. So the persistent connection is used so that the backend can schedule checks on it and say, hey, I need you to run this thing. At the same time, the agent uses the same connection to push the data back.
I mean, from an initiation point of view, can the backend initiate the agent, like just from a firewalling point of view, or?
No, it's all agent to backend. So the way it traverses is you expose one port in your backend via a firewall, what have you. All your agents connect, multiple clouds, multiple WANs, what have you. And then they maintain the persistent connection. So the backend itself doesn't actually need to understand where your infrastructure is and where it is, because it all comes up and says hi, with credentials, of course.
Okay, if you have any other questions, I think Sean will be around.
Yeah, I'll be around all day
also tomorrow,
today and
probably.
tomorrow. Yeah.
It's lunchtime now, but I want to say thank you very much for being here.
Oh, sweet. Thank you very much. Awesome.
Sean
Thanks
Porter.
again, everyone.